Oh, okay, so h of x equals negative x plus 6 squared.
That's it?
That's the
Okay. What is the base function or the simplest possible function that was used to determine this?
X squared.
It is. So the base function is x squared. So then there are two transformations here, but they have to be presented in the order of operations. What will be the first step?
It'd be the horizontal shift.
Yes, so the first transformation is x plus 6 squared, which is indeed left 6. Then the next transformation is negative x plus 6 squared, which is no longer a transformation on this, but it's a transformation on this. So which transformation is that?
Reflection on X.
Reflection with respect to the x-axis. Reflect with respect to the x-axis. Excellent. So when we graph them, you will have to start with the graph of the base function, which is this. It's not perfect. It's a rough estimate, of course. Then you're going to shift it 6 to the left. And you get this. And then you will have to reflect it with respect to the x-axis, which is this. And if I ask you to find the vertex of this parabola, very good, indeed. Okay, so let me give you one example. And I refuse to graph this. Let's just think. Ready to think? Which base function we use here? So you can understand how useful this is or how powerful this is as well. Which function was used?
Absolute values.
Okay, this is the graph. Where do you shift it first?
To the left.
What now?
Of 3. Reflected.
Order of operations. Order of operations, and then
Shift up 3.
I'm done. I didn't even graph the function. One more time. At the origin, 4 to your left, reflect, up 3. Do you picture the graph? Of course you do. Right? We can graph it.
Is there a way of looking at it with like x equaling a value to see like what it actually does when the value is indicated? So
Oh yeah, you can. But the reason why I don't expect you to plug in numbers is because when we use transformation, we want to graph like that. So when I plug in the graphing calculator, for example, I make an error, I see something else, I say, wait a minute, I know the graph. It's this, it's this, it's this, and this. So how can the graph appears this way? So obviously I have an error. I don't expect you to graph accurately. This is not for that. You can plug in as many x values you want and determine as many values of y as you want and plot all ordered pairs and make it an accurate graph, but this is not for that. This is for this. No points, or very few points, at least maybe the x and y intercepts, but no work. Just to picture the graph in your mind. Yeah. Oh, can you tell me the range? We haven't graphed this function. Can anyone give me the range of this function?
Negative infinity to infinity.
Careful. One more time.
Negative infinity to 3.
That's it. You didn't even graph it. You just looked at me looking silly, and you determined the range. That's the purpose of transformations, to picture the graph like that and see where it's going and what it's doing. But if you want to plot points, it's a different story. Then you are not using transformations. And we cannot use transformations unless we know those basic functions. Because if it's a combination like this, you are not going to be able to do anything. For example, let's say this. It can use any transformations. We don't know how. It has so many different complicated situations there. You can use transformations on this. That's why chapter 3 comes after chapter 2. But this, yeah, I can graph it in a blink. This one, I have no idea. We will learn in chapter 3. So here, very easy to use transformations. Here, transformations are useless. I won't be able to use them to graph. There is another function that we are going to talk about in chapter 3, and 2 more that we're going to talk about in chapter 4. This is this one. We know what it is, but we've never graphed it, really graphed it. I can use transformations on this one as well. But if I have something like this, transformations are useless. I can't graph. No way. It's a combination of 2 different functions. It's not a chain of transformations on one function. It's a combination, or addition, or subtraction, or multiplication of different functions that I have. I know how this one looks like. I know how this one looks like. I know how this one looks like. But combined, have no idea. In this case, I have to use points if I want to graph that. As many points as I need. Of course, from 0 to infinity only, because of the square root. So transformations are limited to very simple functions, one function, and transformations on one function only. Ben, you want me to graph this, or is it clear?
Yeah, it's okay. I'm just practicing plugging X values to see what happens to the Y value.
Sure,
Yeah.
of course. Anything else? Other questions? Is there anything else? Which one?
That one, yeah.
Which one? You want to graph this one? Oh, yeah. Exactly what we just said. So we are going to graph the absolute value of x. We are going to shift it forward to the left. So this is the absolute value of x plus 4. This is the absolute value of x. Then we are going to reflect it in the correct order of operations. So this is negative the absolute value of x plus 4. And then we have to shift it up 3. So 1, 2, 3, up here. Notice that I have not determined the x and y intercepts. I don't know where exactly the function is crossing the x and y. I have no idea. I just needed a quick graph using transformations. And therefore, indeed, the range is between negative infinity and 3. Good. Very good questions. Anything else? Yes, please. No, go ahead.
Could you explain,
Yes.
whenever you're combining functions with a quotient, that's supposed to be all real numbers, because I kept getting not real numbers.
So can you give me an example?
That f of x equals x, 2x minus 1, and g of x equal x squared plus x minus 2.
Like this?
Yes.
Okay. And what are we asked to determine?
Determine the domain of each function.
Okay. So you want to find the domain of f plus g. Is that what you mean? F minus g of x. Yes?
Yeah, but when it's a quotient, I guess when it's
Okay, so both are polynomial functions. As we know, polynomial functions are always defined on everything. So this is also the common domain because both are polynomials. So then the common domain is all real numbers. These 3, this is always carved in stone, will have the same domain with the common domain. So the sum, the difference, and the product will have the same domain. So you want to focus on the ratio, correct?
yeah, when it's f over g.
Okay, so now we cannot say anything about f over g till we see it. So f over g of x equals f of x divided by g of x, only if g of x is not 0. So then this function will be 2x minus 1 over x squared plus x minus 2. I don't want the comma, I want the equal symbol. And then this is x plus 2 and x minus 1. So as we know from the first day of classes, you have to state this. In case they ask you the domain of this function is no longer all real numbers. Is the domain of the ratio is negative infinity to negative 2 union negative 2 to 1 union 1 to infinity. In plain English, anything but this. As we know from solving rational equations, the main denominators again cannot be 0. We have to state restrictions every time we have a denominator. If it's an equation or if it's a function, I have to state the condition that the denominator is not 0. Does that solve the problem?
Yes.
Perfect.
Makes sense now.
Thank you. Anything else? Other questions? Anything else for me? Anything else? Okay, so we left it off at function composition. So we looked at, no, we only looked at one example and we haven't finished that one either. So let's continue. I'm going to copy the functions we came up with. So we came up with 2 functions. Oh, that's what you're asking. We haven't even gotten to that. Oh, I see. Sorry. Yes. Good. You're way ahead of me. That's awesome. So we had 2 functions, f of x equals x squared minus 3x. I'm copying them from the previous lecture. You probably have them already. And we determined that f plus g was, and you have that in your notes, negative x squared minus 3x minus 4. Of course, the common domain is the domain of both because they are polynomial functions. And polynomial functions are very friendly. They are defined everywhere, always. So they are, then therefore the common domain is negative infinity to infinity. Okay, now let's take a look at the difference. F minus g of x, I will write the definition first. It's f of x minus g of x. I will copy f of x, which is x squared minus 3x, but subtract in parentheses negative 2x squared minus 4. So this reminds me that I have to distribute the negative symbol, or negative 1 if you want, before I do anything else. So therefore we have x squared minus 3x plus 2x squared and plus 4. And this is 3x squared minus 3x plus 4. And this is a new function. How was this new function determined? It was determined by subtracting the given functions. So always, as I mentioned a minute ago, the common domain is always the domain of the sum, the domain of the difference for any 2 functions, and the domain of the product. Notice that I did not add to the list the ratio. We don't know anything about the ratio before we see it. And let's look at the product now. Stop me if you have questions, please. There's a lot of writing in this section, but it's just writing. It's not really anything difficult, I would say. I shouldn't use the word difficult, so forgive me, I'll take it back. Till we get used to it, it appears to be kind of long and cumbersome. So f of x, I replace it with x squared minus 3x, and then multiplied by negative 2x squared minus 4. These 2 are 2 binomials. I'm just going to use FOIL to distribute, combine like terms, etc., etc. So it's up to you how you want to multiply. So I'll multiply from here, and I get negative 2x to the 4th, then this minus 4x squared, then this plus 6x cubed, and then this plus 12x. There's nothing I can combine, but I will rearrange it. I don't like this. It's not correctly in descending order, arranged in descending order. And this is a new function. How was it determined? By determining the product of f and g. And we have one more so far. No problem. So the ratio now. So this is f of a g of x, which is f of x divided by g of x. I copy x squared minus 3x, and I copy negative 2x squared minus 4. I will factor out in the numerator what, and in the denominator what. There is nothing I can do. There is no need to write that this is not 0, because it's always anything but 0. It's a positive number plus 2. A positive number plus 2 can never be 0. So it happens that for this situation, the domain of the ratio is the same with the common domain, because there are no restrictions on the denominator. Okay, any questions? We do have a fourth method of determining new functions. These were 3 methods: adding, subtracting, multiplying, and dividing. 4 methods: adding, subtracting, multiplying, and dividing. There is a 5th one: function composition. Okay. Totally different. Has nothing to do with adding, subtracting, multiplying, or dividing. Completely different. I'm sure you've seen it before. It doesn't matter. I'll present it from scratch. So here's one possibility. We read this f comp g. You can also read it as the composite of f and g. It's up to you. In short, f comp g. We also have g comp f. We have f comp f, g comp g, and we can go on forever with 2 functions or more. But the question is, what does this mean? Okay, it looks interesting. But what does it mean? So let's start with f comp g. By definition, this means f of g of x, which means this function, which is the closest to x, is the inner function, and this one is the outer. It's the function that is applied to the inner. This is the inner, and this is the outer. Okay, again, you can say this looks interesting, but let me show you with bubbles. Well, I mean sets. Okay. I claim that we apply, in this situation, we apply g to function g to x first. Okay, fine. Here's my x, 1, 5, 10, negative 3, whatever. I apply g to it. What do I get? G of x. And now to this number, whatever the number is, so this becomes a number, I will apply which function to it? Function f, to get f of g of x. So if g of 1 is 10, then I have to apply f to 10, and I get a number. G is the inner function because it's the closest to x. In this situation, f is the inner function because it's applied first, and then g is applied to f. So this notation will be g of f of x. Okay, a question for you. I don't expect you to know the answer. Do you think that these functions have to have a common domain? The answer is no. They do not have to have a common domain whatsoever. I'm not going to ask you, I think you're going to find a problem, maybe two problems, in which you're asked to find the domain of the function composition. Please bring them to class. But I will not test you on that. I don't think it should be part of this course. But I will show you what can happen. Okay, so forget about function f. Can you please tell me for function g, what does this set represent? Excellent, thank you very much. Indeed, is the function, is where x is picked from. Domain of g, of course. Okay, then what is this function, I'm sorry, what is this set for the function g?
Range.
Of course, this must be the range of g. Excellent. For a moment, forget about g. Please tell me for function f, what does this set represent? Thank you. So here is the problem, potential problem. So this is domain of f. So here's the potential problem. Let's suppose, I have to go to the next page. So here's a potential situation. Let's say x is 5. In here, I apply g to 5. Let's say I get 10. And let's suppose function f of x is 1 over x minus 10. So now I'm telling you, plug in 10 from here, plug in or apply f to 10, and tell me what number you get. Undefined. So this is the problem here, potential problem that we may run into. The middle set has to work well. Whatever g is bringing, f has to be able to be applied to it. If f cannot be applied to the numbers that g is bringing here, then the chain is broken. But this is slightly of a more sophisticated type of problem. We do this in pre-calc, so I'm not going to ask you to determine the domain of the function composition. If you encounter problems, please bring them to class so I can show you. Okay? If you find in my lab math. Okay? So the problem here is not whether they have a common domain or not. The problem here is that the range of the first function and the domain of the second function have to work well. Otherwise, the chain is broken. Because whatever this one brings, the other one cannot be applied to bring us to the last set. So if they work well together, the first set ends up to the third set. But if they're like this, whatever this one brings, this one cannot be applied, we cannot make it to the third set. But do not worry about that. Okay, any questions here? Okay, let's see with giving it to functions, please, so we can apply them to function composition. So the problem in function composition is not whether they have a common domain or not. Okay, so give us two functions.
X squared plus 1 and the square root of 2x.
Excellent. I doubt that they are asking us for these problems to find a function composition, but let's say we find that we need to find a function composition. It's possible, but I think they're more asking maybe the sum or the difference or something, but it doesn't matter. They're perfect functions. Okay, so we are asked to determine f comma g and g comma f, and I am going to make a note and say, assuming all conditions are fulfilled. By that I mean, I am not going to research whether the process can be done or not. I'm going to assume that it can be done. I'm not going to determine the domain of the function composition. It's possible but that maybe one way or the other, either f comma g or g comma f, is not possible. But we're not researching that. We assume that conditions are fulfilled and they exist. Okay, I write the definition, f of g of x. I write f do not cross it out like that. I'm just making a point. Replace g by the square root of 2 minus x. And then look at f. F says, I'm looking at the time for a second. Yeah, 25. So f says blah squared plus 1. Can anyone tell us what the blah is? I know it's silly to say that, but you know what I mean. This is my blah. And this is my blah. Blah squared plus 1. But now this is what I have to plug in. So what do I write?
In parentheses, square root of 2 minus x squared.
Very good, which is 2 minus x plus 1. Awesome. In descending order, negative x plus 3. This is a new function that was created with a function composition of f cum g, where g was the inner function and f was the outer function. Okay. Now we are asked to find the opposite, the reverse order, I should say, not opposite. So this is g of f of x, which is g of x squared plus 1. Remember, I have to replace f of x, the inner function, first. And now I look at g. G says you must perform the following operation. The square root of 2 minus blah. So how do I write that? I want the square root of 2 minus whatever. This is my whatever.
Square root of 2 minus, in parentheses, x squared plus 1.
Exceptional. Thank you. That's exactly what I was hoping for. So then this is 2 minus x squared minus 1, which is the square root of 1 minus x squared. Notice the assumption. I did not check whether anything here is possible or not. I have not determined the domain of either one. I just had faith and said, okay, I think it's okay. I hope it's okay. Very good pick. I would like to look at a word problem and also reading from a graph. And do not pick the same problems. These I left them here. This is what they picked. My other class picked. So please do not pick 86 or 95. I'm kidding. It's up to you. I'll let you pick whatever you want. Okay, so let's read from a graph. So here we can read from this graph. We can read anything you want. Obviously, I'm going to write it here and then copy it because I don't want to go back and forth till we finish. So let's choose a problem in which we're asked to blah, blah, blah. And the graphs are here. This is the g of x in purple, and here is f of x in blue. Which one would you like to look at?
88.
I'm sorry?
88.
Okay, so find the domain of f of a g is a different story. So then we have to graph it first. Okay, we have to graph, because find the domain. First, I would prefer graphing it. Or you can say, I see that the domain, but see, I have to make sure that there is a common domain. First of all, can anyone give us the common domain?
-4 and positive.
-4 to +3, very good. So the common domain, and you picked 88. -4 to +3. Perfect. Then I have to make sure that g is never 0. Let's follow g. Since g is in the denominator, I have to exclude, definitely, and I have to exclude 3. Right. So then the domain of the ratio f over g will be -4, 3. That's good enough. I don't need to graph it. But I would like to choose anything else as well, so you can see how we determine any value. Which one? Let's do 85. So fg of 2 f g of 2 is f of 2 times g of 2. So let's look at the blue and please tell me f of 2. F of 2 is? -1. F of 2, I'm sorry, I was looking at G. No, I was looking at F, yes. F of 2 is -1. Very good. G of 2 in purple. G of 2 is 1. So -1. I'll copy that for you in a minute. Let's also look at the function composition. Ready? Here's the graph. Oh, no one can see it. Here it is. Stay. Okay, so let's choose. F comma g of -1, g comma f of 0, or whatever else you want. Which one? Okay, so g comma f of -1, by definition, is g of f of -1. So let's find f of -1. F is in blue. F of -1 is 1. So now I have to find g of 1. G of 1 was a purple. G of 1 is -1. Good. And now I would like to look at a word problem. Any questions? Ah, I can write with that. So we picked 88 on 311, and we had the common domain was -4, 3. The domain of the ratio is -4, 3 because g of -4 is 0 and it cannot be 0. And g of 3 is 0 and it cannot be 0. Maybe I shouldn't cross it out. It's just equals to 0, but we have to exclude that. Okay, the other one was 85. In 85, we had fg of 2, which is f of 2, of course, times g of 2. And f of 2 was -1. G of 2 was 1, so the answer is -1. And we also picked 94 on the same page. And that is g comp f of -1, which is g of f of -1. It happened that this was 1, so g of 1, it was -5. Okay, now I would like to look at a word problem to see an application of this. It's quite neat. Okay, the 102 on page 312. The regular price of a pair of jeans is X dollars. And we're given two functions, f of x and g of x. F of x is x minus 5, and g of x is 0.6x. Like we had a few minutes ago, we were given two functions, and we did our thing with them. Okay, so let's see the first question. Describe what functions f and g model in terms of the price of the jeans. So x is a regular price. So imagine that it's $20. How much will you end up paying?
$15 for the first one and then
12
$12 for the
for the
second.
Excellent. So I was only interested in the first one, but as I said, you're way ahead of me. That's awesome. I have to try to catch up with you. Okay, indeed. So x minus 5 is a $5 reduction of the regular price. Would you agree?
Right.
Okay, $5 off. What does the second one represent?
The second one,
Yes, how much off?
60%,
This is what I pay. How much off?
40%.
Exactly. So the second one is a discount of a 40%, right, of the original price because I'm only paying 60%. And the first one is a reduction by $5. Excellent. Now let's see what they want next. Find F comma G and G comma F. Okay. So let's find F comma G and G comma F. I have to write the definition. I know it's a lot of writing in this section. I'm sorry about that. I have to write F of G of X, which is 0.6x. And I'm waiting for you to tell me what it is, what it equals to. You have nothing to calculate, you just have to tell me how to write it.
Parentheses 0.6, parentheses x minus 5. Empty on a parentheses.
Without parentheses, how do I write it?
0.6, parentheses x minus 5.
I cannot. If I put parentheses like this, then I'm changing the problem. So remember F of blah. Look what F says. F of whatever is whatever and then minus 5. Is that clear? So whatever minus 5. If I put parentheses, I change the problem. Is that clear? Perfect. Can anyone explain now what this represents? What it represents?
40% off an additional $5.
Exactly. 40% discount, and before we pay, they take off another $5. 40% discount, then at the end, also minus 5. Is that clear? Yes? Good. And what about G comma F? This is a perfect example of what we're trying to do here. This is by definition G of F of X. I have G and F is X minus 5. And now let's look at G, which is 0.6x, 0.6 blah. And now this is exactly what you're trying to tell me. This is 0.6 times x minus 5. Because it's 0.6 times whatever. So it's 0.6 times whatever. And then this is 0.6x minus. So 0.6 times 5 is 3. Can anyone explain what this is? And then the problem is asking us to choose which one is better. I know it's not by much, but which one is better?
First one.
The first one. Because the first one says 40% off and then 5 off. This one says 40% off and then minus 3. I know it's not a big deal, but it's a better deal for us.
It's money.
Yes. Questions? Questions? Okay, let's move on.